All right, so now we're going to shift gears a little bit. We're going to talk a little bit about how capacitors work when they are put into circuits. So in one of the early videos that we talked about thinking about how current works, we talked about putting a set of plates that have charge on them, one with positive and one with negative, and connecting them by a wire. And we were able to talk about then how an electron current would flow onto the positive plate from the negative plate, thus neutralizing both the positive and negative plate. That is, you're removing electrons from the negative plate, making it have net zero charge, and dumping those electrons onto the positive plate, moving towards net zero charge. The other thing we talked about here is how that process happens in a non-constant fashion. It happens very quickly at first, and then it happens more slowly as time goes on because there's less charge difference between the two plates, and thus less of an electric field to sort of drive this. And we can think about this in terms of the surface charge density. Surface charge gradient changes as we go along too, and it becomes less gradiated over time. Now the thing we didn't say about this is this actually happens really, really, really fast. So the process occurs in fractions of a second. So this can occur in something like 10 to the minus to 10 to the minus 9 seconds. It's very, very quick because there's really not a lot of, there's not anything really stopping this from happening quickly. If the plates are made out of really good pieces of metal, if the wire is made out of a really conductive metal, it can happen really, really fast. Now a way to slow that process down to observe it is discharging a capacitor through a resistor. So this is a light bulb, which is a really nice resistor because it lets you see what's actually going on in this situation. And by putting this thing in the circuit, what we're doing is we're lowering the overall current that's going to be driven through the circuit, as we talked about earlier, right? For a given potential difference, we expect the current to change depending on the resistance. In the first case, we have a very, very low resistance, so the current's going to be very high, and so this process is going to happen very quickly. In this case, we've put something that has some resistance here, and so the initial current's going to be very low, and we're going to be able to watch this process happen. And in fact, by picking the right kind of capacitor and the right kind of light bulb, this kind of process can happen over the course of 1 to 10 seconds. So it can be really quite observable. You can see the light bulb light up and then dim as it goes out. And that lighting up and dimming process is exactly the process that we're talking about here. At first we have high current, which means that through this light bulb you have a lot of electrons going in there and banging around, making the light bulb really bright. But then as time goes on, the charges sort of distribute themselves and you start to neutralize what's going on up here, and so there's less and less current, and so that shows up as dimmer and dimmer bulbs. So this idea of discharging a capacitor tells us a little bit about how this current process happens. Now one thing to mention here is that in neither of these cases are we talking about a steady state situation. Neither of them are steady state, right? Steady state meaning that the current everywhere is going to be exactly the same at all times. And clearly that's not going to be the case. As the light bulb gets bright, it has high current. As the light bulb dims, the current goes down. And we are going to be able to see that directly by observing the light bulb. The last thing to say about this is that the process sort of happens in reverse, if you will, when you're thinking about charging up a capacitor. So if instead you had something that you were using to put charge onto a capacitor, the current at first would be very high again, but then as more charge gets onto the capacitor, the current would start to go down because the charges are sort of crowding up that space and creating electric fields that exert forces back on the charge that's trying to get on the plate. So in the notes there's a discussion of exactly how that happens in detail. So in this video we just wanted to talk about the process by which discharging happens and how we can make it observable, and in fact how we can slow it down to be observable in a time scale that we can understand.